So you might recall that last year at ARC, we were talking about realizing, making real the digital enterprise. And I said, of course, we would look at the convergence of IT and OT, but we at Bentley Systems think there's still a gap. The digital enterprise potential, we say, is created when engineers create digital engineering models, for instance, with our software of this sort. And we would make the digital enterprise real when we take advantage of those digital engineering models as the baseline and the frame of reference, the digital DNA, if you like, for the asset performance of the assets whose projects we deliver. So we suggest that completing that gap and adding ET is what can make the digital enterprise real. This is our portfolio of applications and platforms at Bentley Systems. And I take note that this year at ARC, we're broadening our focus, if you like, beyond industrial to infrastructure and smart cities in going digital. That's a good match for the whole of what we do at Bentley Systems. And I'll point out that in the past year, we're pleased that ARC's market rankings have acknowledged our leadership in all of these sectors of what we call infrastructure. And our endeavor is to bring engineering technology and digital engineering models to realizing digital enterprises across them. So what's new in the year intervening? And so something about our company, we haven't said a lot of late. Our annualized recurring revenues have grown continuously. Now that's 93% of our total revenues, grew 11% last year, and we expect to surpass $700 million of revenue run rate. This year, we have a new bank credit facility reflecting our very good credit standing. So we've invested over $1 billion in R&D and acquisitions in the past 5 years, grew our company to about 3,500 in the past year. China and Africa grew more than 20% in the past year, as did these of our brands. And speaking of Siemens, by arrangement with Siemens, Siemens accumulates Bentley shares as a long-term investment when our retirees sell those on the NASDAQ private market twice a year, and now Siemens is a 9% shareholder in Bentley Systems. And we work closely together, as I'll conclude with today. So the bulk of our revenues are from outside North America. That's where our colleagues are as well. But in that regard, I call your attention to our annual Be Inspired award categories chosen by independent juries. 10 of the 19 were winners from China this year for the first time. In all of these categories, the winners chosen by some of you on independent juries were from China. And I call attention to this one in particular. Here's the Design Institute, which designed this major hydro project in China, and it is a meritorious, deserving one. It's the same Design Institute, however, for the first time, which likewise broadened its interest from industrial to infrastructure and digital cities. With this playbook, this is the way that they redesigned the city of Shenzhen and its central area for the population of 1 million, bringing their experience in going digital and industrial to the smart city. What China has done is paired up its industrial design institutes with their major cities to be the BIM champions in those cities. And you can see the quality of the work done in that respect. So we say a connected data environment between project delivery and asset performance is what's possible and makes going digital possible. When we go digital, the work of engineers for one purpose is found and utilized by other computer programs for other purposes. And we suggest that can start now with the digital context, and every project and every asset occurs in an environment which can be more or less continuously surveyed with ordinary digital photography. This is the Siemens Process Automation World Demonstration Plant in Karlsruhe, Germany. And here you see a reality mesh model created from those overlapping photographs, and it is engineering ready to go into any of our applications to be engineered for performance and improvement. What's new in 2017 is that laser scanning is now added. And for instance, is now, as in this project in China, a combination. The reality modeling process can now use inputs consisting not only of digital photography from drones or ordinary cameras, but also where laser scans exist. On the left here, you see the result of the laser scanning. On the right, you see the hybrid result from adding the laser scans to the photographs taken inside this plant, and you can see the improved quality. When you just use cameras and drones, dark places are a problem, and flat white surfaces are, for instance. So the combination now in hybrid allows these reality meshes to help realize digital enterprises. Also, during the past year, our context capture software is now a mobile software utilized, for instance, from the cell phone, where photographs taken in the field here are processed in our context capture Azure cloud processing to result in immediate download of, for instance, this could be part of an inspection workflow. And then the final new development in reality modeling is infrared capability can be processed into the reality mesh, for instance, to look at the operating temperatures in an environment like this. So overall, the digital context capabilities were the best overall solution in this year's reliability conference. So the next suggestion is digital workflows can take account of digital components, so that demonstration plant in Karlsruhe is represented by the digital components of the digital components which make it up. Now, when we put that together in digital workflows, let's consider in project delivery what I might call constructioneering, where surveying and construction workflows are part of the engineer's work. And this was the discussion of the chief engineer of Shell at our conference, and they have just described in a project that's almost at completion now the advantages they got. They call it 4D and 5D of this particular advanced work packaging and workface planning digital workflow. This has sound. Let's see if we can hear it. What do you know?
Project Vantage is a suite of tools that enable our construction management processes. It really makes our people a lot faster by automating a lot of the stuff they would normally have to do by hand. From an owner's perspective, it also allows us to see that data so we know where we are on the job at any given point, and allows us to really focus in on where potential issues are and get involved where it makes sense. 4D, 5D is the next iteration of the 3D model. 4D integrates it with the schedule so you can see how the plant is going to be built over time. And then 5D is when you start getting into visualizations with different pieces of data. So we can actually color the model based on what material is here on site and what material is not on site. And this enables us to very quickly look at what packages are available to work and which ones are not, and where we might have to look into our procurement side of things to see what needs to be expedited.
So we can go in and pick a few pieces of pipe, and it builds the packages in a quarter of the time that it takes to build a manual package. It gives us everything that is required to do an installation work package in the field.
That's the inflection needed to finally bend the curve in construction productivity for process plants especially. But let's now go to the digital DNA for asset performance. And we might here talk about converging digital workflows from surveying through inspection. And here's a case in point in an infrastructure example for cell towers. This drone payload is 4 different instruments. It includes, along with cameras, a laser scanner, and an infrared camera as well. And the result here is, first of all, that the reality mesh enables machine learning to recognize the antennas on this communications tower, for instance. And when you know that, for instance, they can solve for the radiation hazard zones around the tower in this respect. And then consider using machine learning to recognize, as here, where there is rust or corrosion. And the digital workflow now includes analyzing and reporting on each of those corrosion zones. So now in the inspectioneer, the engineer is interpreting this corrosion report at his desk rather than needing to go in the field in a hazardous area as in respect here. So I'm going to conclude with operationeering, operating these assets in the field and the digital workflows there. For instance, the connected data environment for the first time at BP, our AssetWise environment is shared between the Global Projects Organization and the Global Operations Organization. So for the first time, the same connected data environment as used here for the on-time delivery of the Kazan project at BP and to enable the connected data environment to support operations right from the outset. And now I'm going to pick up where my friend from Siemens left off in talking about what's possible. This is part of a presentation that Helmut Ludwig, the head of information technology globally for Siemens, presented at our conference. And he talked about our work with all of the Siemens divisions, but I'm going to talk about realizing a digital enterprise all the way from not only diagnosing and detecting and alerting, but fixing problems in the field. So of course we would start with asset performance monitoring and logging, which is so much enhanced by MindSphere connections, as we've all just heard. Now, immersive visibility is possible. Here is that Karlsruhe demonstration plant. And we know that each year the degrees of immersion and the degrees of freedom will improve. This is existing gear that can enable the engineer to consider how to engineer a solution to a problem immersively and with not only visualization but visibility, as we'll show. And when you get down to the component level, this is perhaps a drive for a pump in that plant. We can access the PLM system, Siemens PLM system, as here for the simulation we might need if during operationeering, to call it that. So here is our Mind app that was just referenced, and we're of course able to see the immersively visible reality mesh engineering ready representation, but we can combine that with the 3D models that exist and go, for instance, here to the level of the digital component of which we are tracking KPIs, and perhaps we see a problem in the flow rate of that pump. We can look at its failure modes, and perhaps failure is imminent here, but that might be a problem in this case having to do with vibration that could have resulted from the mounting blocks for the pump, for the motor. And what Siemens imagines in the process of moving to servitization, if you like, is that we might, as here, 3D print in the field a better solution in that plant for that pump to avoid failure and go here beyond at the level of the digital component, having identified the problem, but actually solving the problem by going from the digital context to the digital components and all the way to the PLM solution. So as we consider here at ARC this year for the first time going beyond industrial to infrastructure and cities where things are tied and networked together, this notion of closing the gap that we're at when we converge information and operational technologies with engineering technologies to leverage the digital engineering models is what we're working on successfully with many of our users at Bentley Systems as they are realizing their digital enterprises and going digital. So I invite you, for instance, on Wednesday to join for this presentation by Sanborn Mapping. They are serving the makers of autonomous vehicles by providing the continuously surveyed high-definition environment in which they can test the software for those autonomous vehicles. Very interesting story. And then in the afternoon on Wednesday, please join ArcelorMittal to talk about their digital transformation, which began when they were the first users of our APM software as Dofasco in Canada years ago. And in our Bentley booth, we'll be pleased to talk about some of our initiatives with Siemens, which include for distributed energy resources in a microgrid, for instance, in a process plant environment, how that modeling with our Bentley Open Utilities can improve that environment. Talk to us about other machine learning capabilities in our asset-wise and asset performance modeling environment, and ask us about our new iModel Hub technology, which provides continuous and comprehensive design reviews, the synchronization of change, and puts that all together, and I'll talk about that more next year. In the meantime, please, all of you are invited to our Year in Infrastructure Conference. It was in Singapore, our first road trip from London. We're back in London in October of this year, and I hope you will all join us. You're invited as we continue in going digital. Thank you, and there may be time for a couple questions. Dick.
I'm totally intrigued by your mind app. From an asset performance management perspective, are we able to actually get data from data points from, say, that particular installation there of all those different, looks like motors and sensors and all kinds of things going on in there, and then use that as data to drive an actual APM app? Is that what we're doing?
Yes, that plant exists. It's an operating plant in Karlsruhe at the Siemens Process Automation World, it's called. And you saw sort of the digital context captured there. That was a Siemens person going around and taking some photos, someone who'd never done it before, created the reality mesh, which is your intuitive interface to find every bit of information that exists, including the 3D model that I also showed. And we show how those can be different to see what's been changed over its lifetime. And then the MindSphere inputs are mapped directly to those in digital components, but you see them and explore them in the reality, continuously surveyed, immersive environment of the plant.
So the unit, the installation there is actually, it's a brownfield that you've done context capture, use context capture to completely model that. Then you combine that with your Mind app.
And we have the failure modes and the reliability histories included. So to make that, which is in Karlsruhe, as I say, it's an actual place we can all visit and look at and so forth. And taking that to the rest of the world is what we're working on now with Siemens for all brownfield assets included.
Excellent. That's where it's going.
Yes, please.
I'm fascinated by what you're doing.
Here's the microphone.
Thanks, Paul. I'm fascinated by what you're doing with the factories and the industrial buildings. My concern, though, comes when you talk about smart cities, because city components are not interchangeable. And now China, I understand, of course, has a history of not really caring, and a lot of people have died there because they've just decided to engineer certain things. But other parts of the world are probably not going to be quite so friendly to having their cities engineered. How are you factoring in the human factor in all of this?
Well, it's great. I would really invite you to look at the city that was engineered by the Design Institute, because we don't know if it'll be a hospitable city to live in. Certainly, China describes industrializing, including industrializing BIM, as their approach. And so everything will be manufactured. And it's very interesting to consider how they're advancing that. What we do at Bentley Systems is as much in the public works and so forth workflows. So the very interesting opportunity for us to bring together digital context and digital component is for flood resilience in cities, where the Houston flood cost $125 billion. And we showed the digital component, which is a storm drain. And you can, by surveying it, detect whether it's blocked or not. Of course, our software provides the hydraulic and hydrology model, the drainage models, and our most recent acquisition is an environmental modeling software to manage flood resilience. And you can imagine connecting that all up with MindSphere to say, and connecting that in turn to the weather to say, what are the risks and how can we improve resilience, and very important economic aspects where the digital engineering models from engineers have never been part of the solution before. Very exciting times. Thank you, Paul.